Hi, everybody. This is Joe McIntyre from the Evidence Course Design team. This presentation about some key ideas that we want to think about when assessing experimental evidence is based on the article that we gave you about psychosocial stimulation and labor market outcomes in Jamaica. So without further ado, let's jump into the topic. So we want to start by understanding what experimental evidence is, and we're going to define that somewhat unhelpfully as evidence which is gathered from an experiment. So let's talk about what an experiment is. Let's suppose that we have some group of people, which we'll refer to as our sample, and we have a couple of conditions that we're going to potentially expose them to. And let's say we expose one group of people to one condition where they receive psychosocial stimulation training, parents do. We have another group that do not receive psychosocial stimulation training. And really crucially for the idea of an experiment, let's say that we form these two groups by randomly assigning people to be part of one group or another. At the end of the experiment, at the end of the training, we compare the groups based on whatever outcomes we selected to look at, and the differences between those groups are going to be what we're interested in. So that's what an experiment is, and if we run an experiment, then the evidence that comes from that is experimental evidence. Now, a key idea behind experimental evidence is the concept of a causal question, because most experimental evidence is aimed at answering causal questions. So a causal question is a question about a causal effect, and a causal effect is defined as the difference between what would have happened to a particular person or group or other organization if they had been exposed to a treatment, and what would have happened if they had not been. What we imagine is that for each person in our experiment, if they were assigned to this treatment of receiving psychosocial stimulation, they would have had one particular outcome. If they had not been assigned to the treatment, they would have had some other outcome, not being treated, we often refer to as control. And the difference between these two groups is what we refer to as a causal effect. So the causal question that we're asking in this particular paper, the authors were asking, is did children whose mothers were trained to provide psychosocial stimulation have higher full-scale IQ scores at the end of the experiment than people whose mothers were not so assigned? This is one outcome that the article focused on. This is a causal question because it's about a causal effect. It's about a causal effect because it's about the difference between what would have happened to them if they'd been assigned to treatment and what would have happened to them had they not. Another causal question that we might be interested in asking is, does increasing the number of days that children spend in school in the school year improve their NAEP scores? The NAEP is a national educational achievement test in America, and so we might ask if randomly assigning students to a condition where they have more school during the school year has an effect on their NAEP scores. Causal questions can be very narrow. We might be asking about a particular charter school and ask whether it improves student MCAS results, that's a Massachusetts state test, more than the district public school. So this would be about the causal effect of a particular charter school. Now, a lot of interesting questions are causal questions. A lot of interesting questions are not causal questions. So another question that we might be interested in asking is, are students from high-income families more likely to graduate from high school than students from low-income families? There is no random assignment here. There is no causal effect. We're just asking about differences between two types of students. An interesting question, but not a causal question, and not something that we would address with an experiment. Two other concepts that are really crucial to understanding causal research, experimental research, are the ideas of internal and external validity. We're going to talk about them in the context of experiments, but they're also useful in a lot of other situations. Internal validity, it's basically asking, is the estimated treatment effect, whatever treatment effect we think we have or causal effect, actually due to the treatment? Is it caused by the condition? And essentially what this is asking us is, does the group of people who are assigned to the control to not receive the intervention create a reasonable counterfactual for what would have happened to the treated group had they been assigned to control, and vice versa? And if they do, then we can just look at differences between the treated units and the control units and find the causal effect of the treatment. Studies like the Jamaica paper, where the subjects are randomly assigned to treatment or control, tend to have high internal validity. because the fact that you were in one group or another is purely due to chance. And so the two groups should be no different from each other in systematic ways. They should be identical to each other, except for random chance. In contrast, this study would have had lower validity if parents had been able to change the condition they were assigned to. So if parents could go to the experimenters and say, hey, I don't like this condition, please put me in another one, that would reduce the internal validity, because it could be that the differences we observe are due to the sorts of parents who stick in one condition or another. Somewhat different from internal validity is the idea of external validity. External validity is about whether the findings that we obtain generalize to a wider population. And essentially this comes down to asking, how plausible is it that the results that we observed in this one sample would hold in a wider population? And obviously this won't have a single answer. It will depend in part on how the sample is different from the population that we're interested in looking at, and in part on how we think the treatment actually works. So if we had taken the results of this study and used it to generalize about children experiencing stunting who came from similar neighborhoods in Kingston, Jamaica, then presumably the study would have high external validity. Whatever we found in this sample would presumably also hold in other children experiencing stunting from similar neighborhoods in Kingston, Jamaica. In contrast, it seems likely that it would have lower external validity if the population we were interested in were the population of children whose parents are developmental psychologists. Presumably, developmental psychologists already know most of the content of the training, and it seems unlikely that the training would have much of an effect in this particular population. That's internal and external validity. The last crucial idea we want to talk about is that of replicability. So replicability is the extent to which other researchers are able to obtain the same result as we did, or at least a similar result, when they conduct the same experiment or a similar experiment using a sample taken from the same or a similar population. Can other people get the same results that we did when they do the same thing? So imagine that we take a first study of this phenomenon, the one that we're considering this paper, and we find a positive effect, and it's being reflected by the green shading of this oval. And then let's suppose that 5 other people come along and using similar methods and similar populations, 4 of those 5 studies are able to replicate our basic results, and a 5th study fails to find any association. In this case, we would presumably be more confident in our results because in general, other people are able to obtain the same results as we are. In contrast, let's suppose that our first study is successful, but then of the next 5 studies that attempt to replicate what we found, 4 of them find nothing, and a 5th one finds a negative effect of the psychosocial stimulation training. In this case, we'd be likely to think that our results were probably due to chance or some idiosyncratic aspect of what we had done, and we would be unlikely to believe that these results would generalize. So those are some of the core ideas behind experimental evidence and some of the key things that you should be looking at when assessing the quality of experimental evidence.